Hello everyone. Welcome to the demonstration of data structures laboratory. Today we people are going to demonstrate experiment number 8. The name of the experiment is to design, develop and implement a menu driven program in C for the following operations on doubly linked list of employee data with fields SSN, name, department, designation, salary and phone number. So the operations that are to be performed are create a doubly linked list of n employees data by using end insertion, display the status of doubly linked list and count the number of nodes in it, perform insertion and deletion at end of the linked list, perform insertion and deletion at front of the doubly linked list, demonstrate how this doubly linked list can be used as double-ended queue, and exit. Now let us try to understand what a linked list is. Then further we can move with the implementation part. Linked list is a linear data structure and it is a very common data structure which consists of group of nodes in which each node is divided into two parts. One is a data part and another one is an address part. So this is how each node in a linked list looks like. It will be having one is a data field or an information field and the second field is the address field or the link field. So there are some of the properties that a linked list holds and they are the linked list is a dynamic data structure and it allocates memory as and when required. The insertion and deletion operations can easily be implemented. Stacks and queues can easily be implemented here with the help of linked list. The access time taken by the linked list is quite very small. Linked lists are used to implement graphs, trees, etc. Linked lists let you to insert the elements at the beginning and end of the list. So these operations are quite very simple, or in a easier way it can be implemented when linked lists are being used. So whenever we people use linked list, we need not know the size of the memory in advance. As and when the requirement of a user changes, the linked list can grow or the linked list can shrink. Basically, we have different types of linked list. So the first type of this linked list is a singly linked list. A singly linked list is of nodes linked together in a sequential way, where each node of the singly linked list contains two fields. One is a data field and another one is a link field. The information field information will be stored in the information field and the address will be stored in the link field. So this is how a singly linked list looks like. So here there are 5 nodes with information 50, 20, 30, 10 and 60. So each node you can see there are two fields. One is the information field, another one is a link field. Information field is holding the actual data and the link field is holding the address. The second type of the linked list that exists is a doubly linked list is a linear collection of nodes where each node is divided into three parts: information, left link and right link. Information field is a field where actual information is stored. Left link or L link is a pointer field which contains address of the left node or the previous node in the linked list. And R link or the right link, this is the pointer field which contains the address of the right node or the next node in the linked list. So pictorially, a doubly linked list can be represented in this way. So here we can see there are 5 nodes with the information field 5, 10, 20, 30 and 40. Each node will be having 3 fields. One is an information field and the second is the link field, that is a left link field, and the third field is the right link field. In the information field, the actual data is stored. In the left link, the address of the left node will be available, and in the right link, the address of the right node, the next node information will be available. The third type of the linked list is a circular linked list. A circular linked list is nothing but it is a singly linked list itself, but with a small change where the link field of the last node contains the address of the first node. So that is, this is how a circular linked list looks like. So here you all can see there are 4 nodes with information fields 20, 30, 10 and 60, and the address field of the last node, it is pointing to the first node. So in this way, what happens when we start from the beginning, when we reach to the end of the linked list, it's for us to reach back to the first node. So this is how a circular linked list can be represented. A circular linked list, we can implement it in two ways. One thing is that if we know the address of the first node, then when we reach the address of the last node, then from there we can come back to the first node. The second implementation is we will be obtaining the address of the last node, and the last node will be pointing to the address of the first node. So either of the two implementation can be used, any one of them can be used, and the circular linked list can be implemented. The fourth type of the linked list, that is, it is a doubly circular linked list. A doubly circular linked list is a variation of doubly linked list in which every node in the list has three fields: information, the left link field, and the right link field. The information field is a field wherein the information is been stored. Left link or L link is a pointer field which contains address of the left node or the previous node. And R link or right link is a pointer field which contains address of the right node or the next node in the link. Now, in a doubly circular linked list, what happens is the left link of the first node, it contains the address of the last node, and the right link of the last node contains the address of the first node. This manipulation takes place in a doubly circular linked list because we are converting this doubly linked list into a circular manner, or we are representing it in a circular fashion. So what happens? The left link of the first node points to the last node, and the right link of the last node, it points to the first node. So by doing this, this doubly linked list becomes a circular doubly linked list. Okay, so this is about the types of the linked list that exist. So coming down to the experiment that we need to implement. So here people are going to implement a employee database. We people have to read the information such as SSN, that is a universal serial number provided to each employee. Then we need to read salary, phone number, designation, name, and department. So these all information we need to store in a singly linked list, in a doubly linked list. So for that, the first thing is that we require a node structure. So this node we can represent using a structure. So we'll take struct node. In this node, these all informations we people will be defining it. So we require SSN, salary, designation, name, department, phone number. Apart from that, we also need one more information, that is we need another two information. The one is the left link and another one is the right link. Left link will be holding the address of the left node, whereas right link will be holding the address of the right link. So in order to implement a employee database where all the information of the employee pertaining to their serial number, salary, phone number, designation, name, and department, in order to store it, we are going to use a node wherein in this node there will be 8 fields. The first field will be the left link field and the last field will be the right link field. And then we will be having SSN, salary, designation, name, department, and phone number. So for this program, each node that will be created, we will be having 8 fields. But for our understanding, when I am explaining how the insertion at front take place and deletion at front take place, or insertion at rear or deletion at rear takes place, I will be using a linked list with 2 fields only and explain how the insertion and deletion is been done. But actually, the node consists of how many fields? It consists of 8 fields: left link, right link, SSN, salary, designation, name, department, and phone number. So the node structure is of this type. So in that node, these are all the members. So in order to access these members, we require a variable. So for that, we use a user defined data type, that is type def, and we will create a variable called as node. And in the future, whatever the references we do to the members of this structure, it will be the help of this variable node. Now the first operation that we need to perform on the doubly linked list is to insert the node at the front in the doubly linked list. So in order to insert the node at the front, what all information we people will be reading? We will be reading SSN, salary and phone number from the keyboard. And then the user has to read the designation, name and the department. After reading it, then we need to create a temporary node. And for that temporary node, we have to allocate the memory. Then these all information should be stored into the temporary node. So the information such as SSN, salary, phone number, designation, name and department should be stored in the temporary node. Then the temporary node will look like this. Then after creating the temporary node, the information can be stored into the doubly linked list. So how this insertion is been done? To understand this, we are taking a doubly linked list wherein there are only three fields. One is an information field and the left link and the right link. So this information field, I have kept it as one because if I try to represent a node with 8 fields, and with 8 fields if I try to represent a linked list, then it is not possible for me to represent it on a single paper. So I have kept the linked list as simple as possible. So this here there is only one information field. You can assume that there are 8, say 7 more information fields are available in the node. Okay, so here we are taking only the information that is 5. So the left link and the right link is a must, so that is been kept here. Now in order to insert a node at the front, so first thing is that we require a temporary node. So temporary node is been taken. In that the information field is stored. Then we check whether it is there exists a empty list. So if the list is empty, then the first will be null. If first is null, then simply return the temporary node. So whatever the temporary node is been created, that itself will be the node that will be returned. Then next, if there are more than one node in the linked list, means the list is not empty, then the else part will execute. In the else part, these two statements will be executed. That is, temp arrow right link is equal to first and first arrow left link is equal to temp. So these statements are to be executed. So we are performing the insertion at front. So assume that we have a linked list which is already having 4 nodes. Okay, then we are trying to insert the node at the front. So we will take the temporary node at the front of the doubly linked list. Then we will perform the operation temp arrow left link is equal to, sorry, temp arrow right link is equal to first. That is the upper arrow we will establish by using the statement temp arrow right link is equal to first. Then we will establish the link between the first and temp by using the below arrow statement. That is, first arrow left link is equal to temp. In this way, by executing these two statements, it is possible for us to insert the node in the front of a doubly linked list. After inserting the node in the front of the doubly linked list, then we need to return temp. Why we need to return temp? Because temp is the first node, so we have to return temp. So this is how insertion at front can be done. The next operation that we people are going to learn is to insert at rear. To insert at rear means to insert at the end of the doubly linked list. Again, to insert at the end, again we require the same information in the node. That is, we require the SSN, salary, phone number, designation, name and department. So these all information has to be read by the user. After that, a temporary node is to be created. Then in that, the SSN, salary, phone number, designation, name, department, all those information should be filled into the temporary node. Then the left link and the right link should be made as null. Then after that, we should check whether the list is empty. If the list is empty, simply return null. That is, return the temporary node as the first node. If the list is not empty, then the linked list should be traversed until unless we reach the position of the last node. Once we reach the position of the last node, then it is possible for us to insert the node. So for that, so the first thing is that we check whether the linked list is empty. If the linked list is empty, it is satisfied by the condition if first is equal to null. If first is equal to null, indicates that list is empty. So whatever the temporary node is been created, simply return the temporary node. Now assume that you don't have a empty linked list, but you have some node in the doubly linked list already available. So here there are 4 nodes available. Then You want to insert at rear, so we have created a temporary node and we have kept this temporary node at the end of the linked list because we are interested in inserting at the rear end. Now first is a pointer which is pointing to the first node in the doubly linked list, but we want to insert at the last, so we want the address of the last node. So in order to obtain the address of the last node, we will use one more pointer called as current, and that current pointer we will make it to point it to first. So we will use current is equal to first. So current is pointing to the first pointer. Then we will check whether current is arrow R link is not equal to null. So what we will check? We will check whether current's right link is not equal to null. So check the link, right link of the current. So the right link of current is pointing to node 20. It is not equal to null. The condition is true. In such a situation, current should be updated to the next node. So the current has come to the second node. Then again check current arrow right link is not equal to null. So right link of current is pointing to the node 30. So the condition is true. So current will be updated by using the statement current is equal to current arrow right link. Then again the statement is to be checked whether current is not equal to null. If the current is not equal to current's right link is not equal to null, current's right link is pointing to node 40, its right link is not equal to null, so the current will be updated to the next node by using the statement current is equal to current arrow right link. So by using this statement, the current is updated to the next node. Now again this while has to repeat, so here again you have to check whether current arrow right link is not equal to null. So current is at node 40. Now we check whether its right link is not equal to null. Current's right link is null now. So current is pointing to node 40. Its right link is null. So this condition in the while has failed. So we'll come out of the while loop. Now we have obtained the address of the last node. Then we have a temporary node. Now we have to establish the connection between current and temp. So how will we establish the connection? We will use current arrow right link is equal to temp. We will use one statement current arrow right link is equal to temp. By executing this statement, this upper arrow is formed. Then we'll execute the statement temp arrow left link is equal to current. Then we'll execute the statement temp arrow left link is equal to current. Then we will execute this statement temp arrow left link is equal to current. So this below arrow will be executed. So we have established the link between the current node and the temporary node. After inserting the node at the rear end, now we have to return first, because first is a node in the linked list which is pointing to the first node here. So we have to return first. Okay, so this is how the insertion at rear end can be done. The next operation that we need to perform is we need to perform the deletion at front. So in order to delete a node at the front, we have assumed that there is only first we have to assume a situation wherein the list is empty. So how do you determine that the list is empty? So the condition to check whether the list is empty is if first is equal to null. If first is equal to null, it indicates that list is empty. If the linked list is empty, deletion is not possible, so simply return null. Okay. Second condition is if there is only one node in the linked list. How to identify that if there is only one node in the linked list? If first arrow right link is equal to null. That is, if right link is null of the first node, it indicates that there is only one node in the linked list. If this condition is satisfied, then we want to delete that node. So what we will do, we will first display the information that is deleted. So here the information 10 is been deleted, we'll display it. Then we will return the null, because the only node, because there was only one node in the linked list, we have deleted it. After deleting the only node in the linked list, remember that first is a pointer and now first is not pointing anywhere, so we should return a null. Okay, so this is how the deletion can be done. The next thing is that we want assume that some doubly linked list already exists. We have some nodes available. So in this doubly linked list nodes, and you want to delete at the first. So the very first thing is that you require the address of the second node. First is a pointer which is pointing to the first node. Now we want to delete the node at the front. So the node that is to be deleted at the front is node with information 10. If at all you want to delete it, you first should obtain the address of the second node and then you have to delete it. So how to obtain the address of the second node? Second is equals to first arrow right link. So how will we obtain the address of the second node? Second is equals to first arrow right link. So in this way, we will first obtain the address of the second. Now, after obtaining the address of the second node, now you are free to delete the first node. Now, before deleting the first node, you have to break the connection between the second node and the first node. So for that, what you should do? Second's left link is pointing to the first node. So this link only we will break because second's left link is pointing to the first node. So we will make second arrow left link is equal to null. We will execute this statement, that is second arrow left link is equal to null. We will make that statement second arrow left link is equal to null. So this bottom arrow what we had, that arrow, it is been breaked. So the link between the second node and the first node we have breaked, and in the left link of the second node we have made it as null. Now we are free to delete the first node having the information 10. Now what we should do is we should free node first. So before freeing this node having the information 10, first display the information by using first arrow info. After displaying it, next thing is that free node first, this node gets deallocated. After that, return second. So what you should return? You should return second. Why you should return second? Because first was a node which was pointed by the first is a pointer which was pointing to the first node. First is already deleted now. The node which was pointed by first, it is already deleted. So first is already null now. Now we will return first. So the second node will become the first node. So this is how deletion at front can be done. The next function that we people are going to learn is to delete at rear. So in order to delete a node in a doubly linked list, the first two steps remains the same. The first thing is that check whether the list is empty. If the list is empty, return null. So what is the condition to check whether the list is empty? If first is equal to null, list is empty. Then simply return null. If there is only one node in the linked list, then that will be satisfied with the condition first arrow right link is equal to null. If that condition is satisfied, then the only one node which is available in the linked list, we want to delete it. So first, before deleting, display the information. After displaying the information, free and then return null. Then this was the two things we have done. The one is we check whether the list is empty. Then we check whether there is only one node in the linked list. Then the next thing is that we should check whether there are more than one node in the linked list. So in the else part here in the code, we are having, say, first is equal to null. This part indicates list is empty. In the else if part, it is if there is only one node in the linked list. This code checks whether there is only one node in the linked list. And the else part, it is for more than one node. This is for more than one node. So first we will use two pointers, previous and current. Previous will be pointing to null and current will be pointing to first. And we will traverse the linked list in such a way that we should obtain the address of the last node. So for that we will be using two pointers. One is a previous and another one is a current. So we will use two pointers. One is previous and another one is current. So assume that we are having four nodes in the doubly linked list and we want to delete at the end. So we are using two pointers, current and previous. Previous is null. It is pointing nowhere in the doubly linked list. Current is equal to first. It is pointing to the first node. Now we have to obtain the address of the last node. So what we will do, we will check for the condition while current arrow right link is not equal to null. Check the right link of current. Right link of current is pointing to node 20. It is not null. Condition is true. So what we should do? Previous should be brought to the position of the current and current should be updated towards the right. So previous comes to the position of the current node and current comes to the position of the next node. Then again check, again the while will repeat. So this while will repeat. Then again you have to check whether current's arrow right link is not equal to null. So current is pointing at the second node, check its right link. Its right link is pointing to address of the third node. So now what you have to do, the current arrow right link is not equal to null, the condition is true. So first previous should be updated towards the position of the current and then current should be brought traversed towards the right. We will get this representation. In this way, the previous and current positions will be found. Then again check current arrow right link is not equal to null. Current's right is pointing to the node 40. It is not equal to null. So previous should be updated to the position of the current and current should be traversed towards the right. So those statements are previous is equals to current and current is equal to current arrow right link. After that again check the position of the, again check the right link of the current. So the right link of the current is not equal to, it is equal to null. So current's right link is equal to null. This indicates that we have reached the last node. Arrow info, and you should make previous arrow right link is equal to null. So we will make previous arrow right link is equal to null and then we will free node current. Free node current and previous is the last node. So after deleting node 40, 30 which was the last but one node, it should become the last node. So previous is pointing to node 30. So it's a right link which was pointing to current. Now it should be made as null. After deleting, we should return the address of the first node. So this is how the nodes in a doubly linked list can be deleted at the rear end. Then the last function that exists is we want to count the number of nodes in the linked list and we want to display the number of nodes in the linked list. To count the number of nodes in the linked list, we are using a pointer called as count and initially it is a 0. And before displaying, we check whether the list is empty. So first we will use a pointer count is equal to 0. We'll use a pointer count is equal to 0 and first is pointing to the first node here and check before displaying, check whether the list is empty. So the condition to check whether the list is empty is if first is equal to null. If the list is empty, simply display empty and return. If not, we should use one pointer current is equal to first and we should make that pointer to point to the first. So we will use one pointer as current and that current should be pointing to the first node. Then we want to display SSN, salary, phone number, name, designation and department. So suitable printf statement will be written here so that the output can be formatted on the screen. Now we have to traverse the linked list one by one node at a time and we want to display the information. So for that we are using one pointer that is current and current is pointing to the first node. So this while statement will be executed, that is while current not equal to null. So current is first pointing to the first node, it is not equal to null. So what we have to display? We have to print the information. So print info. The information will be printed. Then after displaying all the information, now this program is to display the employee information such as SSN, salary, phone number, department, designation, etc. Everything should be displayed. So here you can see current arrow SSN, current arrow salary, current arrow phone number, current arrow name, current arrow designation, current arrow department. Everything is been displayed with respect to each member. The appropriate format specifier is been specified, and the all the information is been displayed. So I am not writing as a print SSN, salary, phone number, name, all the stuff, but simply I am writing print info. After printing the information of the first node, now the current will be updated to the next node by using the statement current is equal to current arrow right link. So current will be updated to the next node. Then again you should check, again this while will repeat. Now check whether current is not equal to null. Current condition is true. So you have displayed information of one node. So count will be incremented. Count will become 1. Then current is pointing to the second node. Current is not equal to null. Again display the information. So print second info. So second info will be printed. So first info was printed. Now second info is been printed. Then current will be updated to the next node towards the right, and count will be updated to 2 because 2 information we have displayed. Then again check while will repeat. This while will repeat. Check current is not equal to null. Condition is true. Then display the third information. Print information of the third node. After that, current will be updated towards the right, count will be updated, it will become 3. Then current is not equal to null, condition is true. It is pointing to the fourth node. Then after that, we need to print fourth information. After printing the fourth information, increment the count, count will become 4. Now update the current, current null because 40 was the last node. Current was pointing to the address of the last node. Now current is updated towards the right. Now many information will be displayed. So there were 4 nodes. Current was traversed 4 times. Count was updated with value 4. So number of employees 4. So this is how the nodes in a doubly linked list can be traversed. So coming down to the main program, here we have used one pointer called as first, as first is a pointer. So as a good programming practice and not to make a pointer a dangling pointer, we are initializing first to null. Then 2 variables choice and item are being taken. Then we need to create a menu driven program. So in order to make the menu driven program, we are writing the printf statements here in this way. So menu 1 to insert front, 2 to insert rear, 3 to delete front, 4 for delete rear, 5 for display, and 6 for exist. So based upon the choice given by the user, if 1 means to insert at front, 2 to insert at rear, and so on. So based upon the choice, appropriate case in the switch will be executed. If the user hits 1, insert front function is called. If the user presses 2, insert rear function will be called. If the user presses 3, delete front function will be called. If the user presses 4, delete rear function will be called. If the user presses 5, the display function will be called. And if the user presses 6, the program will terminate, because this do while loop will repeat only up till the user gives choice 1 to 5. Once the choice becomes equal to 6, the program terminates. So this is how the menu driven program for implementing an employee database using a doubly linked list can be written. Now the next thing is that we want to execute the program. So we'll go to the Turbo C. I have already typed the program. Now I will compile the program. There are no errors here. Warnings are there. They are not going to harm the program. So I'll be ignoring the warnings as such. Next thing is we will execute the program by clicking on run. So here a menu is been displayed, that is 1 for insert front, 2 to insert rear, 3 to delete front, 4 to delete rear, 5 to display, and 6 to exit. So at time being I will exit it, and I will clear the screen of the previous execution, and then I will execute the program. I will compile the program. Now I will run the program. Yes, because last time previously when had compiled the executed the program, the previous execution was displaying there. So now what I have done is I have cleared the output screen. So now the menu has been displayed: 1 to insert front, 2 for insert rear, 3 to delete front, 4 to delete rear, 5 to display, and 6 to exit. Now the user has to give the choice. If I give 1, this indicates that insert front. The user when presses 1, the output statement is displayed is enter SSN, salary, and phone number. So if I give the SSN as 121, salary say it is 12,000, then phone number will be entered. Then it is asking for the designation. So I'll give the designation as clerk, and the name is Sonu, and the department is say transport. Some department will give. So this information we have entered. Now we have to check whether the information is been displayed, been entered or not. So for that I will give choice as 5 and display and see. So display, yes, whatever the information was given, it is been displayed. So that is been inserted, and you can see the number of employees is equals to 1 also is been displayed there. Then I will give the choice as 2 to insert at rear. So it is asking me to give SSN. So I'll give SSN as 233. Salary say we will give it as 20,000. Then phone number we will give it as 43456 7. Then designation we will give something like SDA. Then name we will give it as Monu. Then we will give the department as lab, some lab. Okay. Okay. So then I will enter. So the information is been read. Now whether that information is inserted at rear or not, I want to check it. So I'll give choice as 5 and I'll try to display. So you can see the information is been already inserted into the W linked list. So the first information we entered was SSN 121 with the name Sonu, clerk, and the transport department. The second SSN we have entered is 233 with a salary 20,000 and the phone number 34567 and the department as lab. Now the number of employees we have inserted is 2. So in this way, insertion at front and insertion at rear can be done. So the SSN 121 we inserted at front and SSN 233 we inserted at rear. So 233 is below and 121 is above. Okay. Now we'll try to delete. So I'll give the choice as 3. So delete at front will be executed. So 121 which was at front is been deleted. So that information is been displayed there. That is 121 employee SSN is deleted. Now we will display by giving choice 5. So now 121 SSN is been deleted and now that number of employees is 1. Earlier there were 2 employees, now it is 1. Now I will execute choice 4, that is to delete at rear. So SSN 233 is deleted. It is giving the information there. Now I want to check whether the information is deleted or not. I will give choices 5 and I will try to display. Now when I give choices 5, you can see the output displayed is empty. That indicates that the linked list is empty because we entered only 2 employee information, one with SSN 121 from front and SSN 233 from rear. So one insert front we executed and insert rear we executed. Then we deleted one from delete front and another from rear we deleted. Then we displayed. Now the list is empty. So that information is been displayed. Now I want to terminate the program. So I will press 6 and if I press enter, the program terminates. So this is how the lab experiment number 8 can be executed. So with this, we have successfully demonstrated the execution of experiment 8. Thank you very much for patient hearing.